Yeah, and after this kind of eloquent comment on Kubernetes, it's kind of a boring topic, I'm afraid. But let's see what you guys think about it. And I cannot talk about RPKI without introducing it a little bit, the structure, and then we'll go into some more details of how we use HSMs there, and hopefully some nice anecdotes if I manage to weave them in. So first of all, what's the resource public key infrastructure, and why was it done? I think everybody here in the room knows that BGP is a flooding protocol for routing data that's based on trust. A network can send updates. If they do not get filtered, they might get accepted if they're the best option. And if they're the best option, they go further. And that way, mistakes can spread, and also, mistakes can spread, and also some attacks can spread. And with the RPKIs that is currently deployed, operational mistakes of typing the wrong prefix length get filtered pretty well, and some other attacks get a bit harder. And the other part of RPKIs you guys probably know, that you all probably know, is that it's an X509 certificate-based system with a root of trust at the regional internet registries. The regional internet registries have a root certificate, which is a certificate that's signed by its own public key. Below that, there's multiple layers of certificates. And in the end, there are RPKI-signed objects. The root certificates are the certificates of which the public key is the trust anchor locator. That's in the validation software. Below that, there are certificates that are just intermediates for the operation of the CA. In the end, at the RIPE NCC, the members have their certificates, which contain their resources. And each layer of certificates below the top one is signed by the certificate above. And finally, there are RPKI objects, one of which is, and for me the most important one, is the manifest. It's an object that prevents replay attacks and withholding some objects. And this is an example of a cryptographic message syntax signed object, which is a binary blob with, in addition, another X509 certificate that contains the validity period and the resources that apply to that object, and that's signed by the CA certificate above. And there's more stuff, you've heard about it. I think this has been taught here many, many times, this intro. So RPKI to RIPE NCC is done by one team, where we develop the CA software, we maintain the infrastructure, we operate the offline and the online CA, and I'll tell more about those later. We're on call. I'm on call right now. Hope it doesn't beep. I'll jinx it. And we run these layers of certification authorities, and we use two hardware security modules there. One that's held offline, so it's a USB HSM with a laptop. They go in a seal bag together. They sit in a vault, and that's the one that we sign the long-lived things with the Trust Anchor certificate, and every 90 days we take them out. And then there's the online hardware security module, where if you request a ROA to be signed, your public key is loaded from the database into that hardware security module. Your certificate is used, an identity certificate is generated, and that's signed by your key, and your object is made, etc. So we have these two environments, and they're set up in a different way. And one of the keys is a key that we basically cannot roll because it's stuck in this software that's deployed worldwide. So we make this one extremely secure, hard to tamper with. For example, the security vault, that's what the vendor calls the configuration for the HSM, is guarded with a quorum of little smart cards to load data in the HSM or to enable new cards. And you need 3 out of 5 cards to do anything. And if you want to sign something with this HSM, you need to have people from another group of cards. In contrast, the online environment is the HSM that contains all the certificates for the members, the intermediate certificates. So it has around 20,000, close to 21,000 certification CA certificates, and a lower number of manifests because some people do not use hosted RPKI, but they use delegated RPKI. And yeah, I had to prove that I got those numbers for real because 21,000 is quite a few, and people really use this in production. So when I started at the RIPE NCC, it was in the year when people suddenly started to use RPKI in production, and our stuff broke, and it was stressful to run that. These manifests are objects that prevent replay attacks. And it basically means that you cannot serve the same objects again to a validator, and that it would take these objects. That's because they contain a timer, they contain a counter, and also they contain a time window for which they are valid. And when we make these objects, we sign them for a period of 24 hours, and after 16 hours we replace them. That means that when there's an operational problem with these hardware security modules, which basically are one servers with a secure card in there, we have 16 hours to fix it, or it becomes very highly visible. And this is a nice picture from a data center in Amsterdam at a very late evening in June after a double hardware failure, which turned out to be a software bug instead of a hardware failure, but we only found it out after replacing the hardware. That was a good night. These systems have evolved over time, like what we use now are these, I've just mentioned these one-use servers, but what they started with before were these PCI Express hardware security modules, and I included this to really show what a hardware security module really is. It's basically a highly certified PCI Express card with a lot of potting material on there, so you cannot tamper with it. That does some crypto in there. And it's connected to a smart card reader somehow. Back then with a DB9 port, but now in the more modern ones, there's a card reader, not on the photo of this one, on the edge, on the right edge, you see that there's a card slot. And you use the cards to authorize operations on these devices. So, okay, PCI Express generation really has to be in the server. Newer generation, network devices, you get a kind of crazy setup where your application runs on a server. And then it uses either PKCS11, which you probably have heard of by name only, or another cryptography API to talk to a local daemon on the server. That daemon has a connection to the hardware security, to a daemon that's running on the one-use server containing the hardware security module, and the crypto traffic gets tunneled from this local daemon to the network device, to the hardware module on there, and that's all one trusted path. And honestly, the details are probably standardized by FIPS. I know they are standardized by FIPS. FIPS points at an ISO standard, and that means that I couldn't read it because I don't have that one. What is fun about these ones is that this one has its unbroken LED lit up at the left, and that these are actually OpenBSD devices that are out there in the wild and that people run in production. But with the newer ones that we're using right now, they switched to Linux plus the GR security patches. They also claim to use containerization. I don't know how. I think it's for running custom applications inside the hardware security module, really stuff. But what's kind of cool there is that you can fully remote manage them if you want. And that we managed to run these in production on an IPv6 only setup with only one bug that we hit, which was that NTP didn't work as intended, which honestly was not the worst bug we could have hit. As I mentioned, these things are quite redundant. So the local daemon connects to both HSMs, fully redundant, comes with interesting failure modes as well, such as software bugs such as a memory leak, still affecting both HSMs, causing that data center visit that I alluded to earlier. And you can manage these things remotely pretty well, which is especially nice in development. So you use this card with a card reader on your laptop and some SSH tunneling to have a secure connection between your card and the module. You can do everything remotely. You can do the setup of the device remotely using its configuration server and just a telnet serial console for initial setup. So I still live in Enschede and I could do this from home while the things were in Amsterdam, which was nice. Then I've become a huge fan of monitoring and alerting because RPKI shit is kind of complicated and brittle, and we needed to really understand what was happening. It's a standard stack where we also have a lot of application metrics, and I had to learn SNMP a little bit to set up SNMP exporter to get the metrics from the HSMs. So after the fact, with the second crash, we could reconstruct that it was a memory leak that caused the crash. It's always easier to know that you need to find a cause for a crash once it happened. And we spent a lot of time there with these devices, setting them up, configuring it, babysitting our pets, because these devices generally are pets. And they work really well. They're highly certified. You don't know the standards. You have to trust the box. You have to trust the vendor. And honestly, not many bugs in them. But hardware does fail, and especially configurations fail. And it means that if you visit a data center, you do a tiny change there. 5 minutes later, you get paged outside the data center. You have to do a fix right there in the field. Actually, a good memory. Yeah. This is the main thing I wanted to share about working with these black boxes.
Are there any questions for Thies about these magic black boxes?
Yeah. Is the process being audited, for example, for the key ceremonies, publicly?
Yeah, publicly. Oh, that's a good one. The team recently got their ISAI 3000 Type 1, Natalie, correct me if I'm wrong, a statement from the auditor, which the members can request from the RIPE NCC, so you can see what controls there are and what we do. And for example, this offline signing process, we documented in a blog post, documented at the bottom of a blog post. And yeah, we really try to, we rely on the trust of the community, so we really try to be transparent there. Yeah. That's also why we can show this here.
Yeah, all right. Yeah, because DNSSEC, for example, the routines are being publicly observable. That could maybe be an improvement because it's for the entire internet. But thanks.
Yeah, thanks for the question.
Yeah.
Nick, are you want to ask for a ride home because you're from Enschede too?
You can ride with me. My car is near here, so Enschede. But no, my question is, I run a hobby network aside from a network that I professionally run, and I was wondering how much do these HSMs cost if I want to implement such a system for my hobby network? I think it really needs it.
I think you can, the beauty of these professional HSMs is how you can do key management. Like you can do key management with these smart cards, so it's really, and you get a highly certified process of how you do this. There's a lot of controls, you know it works well. If you just don't want to lose your key, I think a YubiKey, anything that implements PKCS 11, effectively it can be a quite good HSM. So the secure element in your computer, the TPM chip, a YubiKey, should all work, technically.
Oh, that's interesting. So I could just put a Raspberry Pi on top of my single server and put a YubiKey in there, and then I have a professional HSM.
Yeah.
Cool. Thank you.
There is also a question from a remote participant.
Well, this time it's not a remote participant either.
Oh.
But yeah, it's still a question. What happens if the offline unit fails? Is that a single point of failure?
It's a really fun question. So the offline unit is, because this almost we had the feeling this was happening, so it's close to my heart. The offline unit luckily is only needed every 90 days, and you have 2 layers of cards protecting it. So day to day, every 3 months, we need 3 out of 10 people to be there to use the current hardware security module. If the device fails, we need to add a new hardware security module to the security vault. So that's terminology for enabling a new HSM to use the keys. And in that situation, we need 3 out of another set of 5 cards. If we don't have 3 out of those 5 cards, it will be a bit annoying.
Okay, thank you.
All right, thank you. I have one request from for Thies myself, and it is please do not forget your card. Thank you, Thies.